right? So let's see the first one, the forward, right? So WDM, actually WDM, the meaning is wavelength division mounting balancing. That is advanced technology for optical fiber communication, and I think now it's the newest technology for optical fiber communication. Okay, and it is mature and has entered the this course will help you gain a basic understanding of the WDM principle. Okay, so in this course we will help to understand the basic concepts, principle, transmission mode, and basic composition of WDM, and then let you know the WDM transmission media, that is fiber, the structure of the fiber, the features of the fiber. Okay, and we will make you have a good commander of WDM technical principle and key technologies. Okay, and I think you will understand the technical specifications of WDM optical transmission systems. Alright, so let's see the first chapters, the WDM overview. Okay, I think before we learn the WDM technology, we always have a big problems for all our network. That is how to increase the network capacity. That is always the problems for all network, because the request become bigger and bigger. Right? A few years ago, we used iPhone 3, which only used 2G network. Now we are used iPhone 10, which used 4.5G network. Right? Maybe a few years later, we will use 5G, 6G. We need more capacity, right? And lower delay for this kind of application, right? So I think for all the network, this is the big problems, how to increase the network capacity, right? For our transmission network, we also have the same problems, how to increase the network capacity, okay? And we already found a lot of different solutions for these problems. Few years ago, we used the first solution, that is SDM, space division mounting balancing. What is space division mounting balancing? If the network capacity is not enough, we will buy a lot of equipment and install a lot new fibers to connect the two stations, connect the two different places. Make more equipment, give us higher capacity. That is the solution. But this solution, you must be very expensive, right? And you will waste a lot of time to install the new equipment and new fibers, right? So this is always the solution. So we find out the next solution, that is TDM, time division mounting balancing. We use it for a lot of years, long time, right? TDM, time division mounting balancing, that is which technology use this solution? That is SDH. SDH transmission network used TDM, time division mounting balancing. We use the higher bit rate boards to replace the lower bit rates hardware, right? For example, a few years ago, you only used STM1 capacity, which is not enough. You need to increase capacity. Then you can buy some STM4, STM16, STM64, which is a higher rate hardware to replace the old lower rate hardware, right? Make you can increase the capacity directly. You don't need to install new fibers. You can still use old fiber. You don't need to buy new equipment. Just buy some few new boards will fix this problem. But it also cost, make you waste a lot of money to the new boards, because after you use higher boards to replace the lower boards will be free. So no place will use it, right? This money will be waste for the lower rent boards, right? And also, which the service is already carried by the older boards. If we want to do this replacement, the service will be affected. For our real life network, it's pretty dangerous to do this configuration, right? So at this time, we find out the new solution, that is WDM, wavelength division mounting balancing, right? For this kind of solution, this is the newest solution, which is very fast, very cheaper than other solutions, okay, and very good. No need too much time, no need too much money to increase capacity. Wavelength division multiplexing means we mixed a lot of different wavelengths into the same fiber to do the transmission. If you want to need more capacity, you just need to add more wavelengths into the same fiber, and you only need to buy the boards which can supply the wavelengths will be okay. Other unit, no need to buy more. Okay, just use the older boards. Okay, and then the WDM also has some limitation. Okay, for example, in the same fiber, we can only allow the maximum wavelength number is only 80 or 160, or the newest solution, that is, we can only allow the 192 wavelengths into the same fiber. The wavelength number is limited, so you cannot just always add wavelength number to increase capacity. So if you need more capacity, so we have TDM plus WDM. So for the older WDM, maybe you have 80 wavelengths. Each wavelength can only carry 10 G, but we can use more wavelengths, and each wavelength can carry higher capacity. This kind of solution to fix the problem, we can use maybe 80 wavelengths, and each wavelength can carry 100 G. You can see the TDM plus WDM together to make your network capacity become higher and higher. Okay, so that's the solution now for our to increase the network capacity, which is very good. Okay, and after we know the advantage of our WDM, so let's see what is WDM. We have a flash for you guys to show you the structure of WDM network. In this flash, you can configure all this gray colored car is customer service. Okay, the highway is the fiber between two stations. Okay, and the gas station, you can consider it as a regenerator station. Okay, regenerator station. Okay, and the proto car, this is kind of like a supervisory channel. So let's see what happened in this flash. Okay, you can see all the customer car, that is customer service, pass through the black line. All the gray car become the colored car. Each car has his own road in the highway, right? Different car use different road in the same highway. They will never affect each other. So that consider like this way. In the WDM system, when we access the customer service, if we want to transmit the different customer service in the same fiber, the first step is we need to make different customer service carried by different color. Different color means different wavelengths. That it means different customer service should carried by different wavelengths and mix them into the same fiber, and then it can transmit in WDM network. Okay, then the protocol is kind of like a supervisory channel. During the transmission, we need to know the status of our service, so the protocol car can help us to realize this kind of application, right? So protocol is very important. Okay, so that is the basic WDM system. So let's see the WDM concept. You see, WDM refers to a technology that transmits optical signals at multiple wavelengths over one optical fiber. Okay, we can use more different wavelengths, mix them together into the same fiber to realize high capacity transmission. Different wavelengths carry different service. They will never affect each other in physical layer, right? So, and for those wavelengths, they can use to carry a lot of different customer service. Can be SDH signals, can be IP package, can be ATM sales. So, we also have other customer service can be carried by WDM network. Okay, so WDM network is very good, right? Okay, so if we want to realize the WDM technology, I think we need a hardware to realize this kind of application. So you can see in this system structure, we have the hardware to help us realize all this kind of application. The first unit is optical transponder unit, which is OTU. So the OTU is the first board in WDM network. So what's the application of the OTU? You can see OTU is used to connect between client-side equipment and the WDM side equipment. So the function of OTU is to make all the customer service carried by the standard wavelengths. That's what I would say. The wavelengths should be standard. If you want those wavelengths mixed into the fiber, same fiber. If the wavelength is not standard, a lot of wavelengths mixed into the same fiber, they will affect each other. All the service will be done. So that is rule 1. All the wavelengths mixed into the same fiber, those wavelengths should be standard wavelengths, right? But as for the customer service, all the wavelengths is not standard. So when WDM network accesses this kind of service, we cannot mix them into the same fiber directly. So before we mix them into the same fiber, we should make all the service carried by the standard wavelengths. So which unit can help us do it? OTU, optical transponder unit. Okay, so this is a major function for OTU. Right? Then, after we use different OTU to connect with different customer service, and OTU will output different standard wavelengths, and those wavelengths is already carried your customer service. And then we can mounting plug them into the same fiber. But you know, we must have one unit to help us to realize this process. That is optical mounting planks unit, OMU. OMU can help us to mounting planks all the wavelengths in the same fiber. Okay, because the OMU is a very big unit, and during this process, it will have a very high attenuation, so I can say insertion loss for your service. Your service power will be decreased. So after we do this mounting planks, we need another unit, OA, optical amplifier, to make your service power higher again. Otherwise, we cannot just send it out because the launching power is too low, right? So you can see why in our WDM system structure we have OM and OU together right over here. Okay, then we can send it out. Before we send out, we still have the last steps, that is OSC. OSC means optical stabilization channel, like our protocol in the flash, you see. So during the transmission, we need some supervisory channel can monitoring our service status, can transmit some commander signals or the wire signals between two stations. So we need one special wavelength to help us to transmit those special signals, which is not service signal. Okay, so OSC will launching this kind of service. Okay, then OSC will mounting planks into the main path and transmit with your client service. Okay, then after long distance transmission, your power will be decreased, right? But we need to make your power higher again, because we want a very, very long distance transmission. If the power is already too low, we cannot arrive at the same station. So in the middle of your network, you may need another unit, that is the regenerator unit. Okay, actually in transmission network, we have two different regenerator solutions. The first one is electrical regenerator, which is widely used in transmission network. This electrical regenerator is very good, has a lot of advantage. For example, it can make your service power higher, okay, and it will regenerate all the overhead. It will regenerate your signal quality, make your signal quality higher again. This is very good, and it will cut off